Hello, Hornets, and welcome. Thank you for joining me today. I'm going to be going over converting or finding ratios from radian values or degree values, specifically degree values in this video, and then we'll take a look at radians in another. Now, in order for us to begin, it is important that you are aware of what the first quadrant values are. Now, hopefully you've already gone through them. I know that I've gone through them with my class, going through the 45-45, 60-30, and 30-60 degree triangles. We've also come up with this idea that these points or coordinates are 1, 0. From the right triangle, we found that this had to be root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and 1/2 root 3 over 2, and we finish with our 0, 1. Now up here, we're looking at a 90-degree angle. Right here, we're looking at a 60-degree angle. 45 degrees, off by 15. And then by 15 again, we have our 30 degrees, and we finish with 0 degrees. Now, it is probably helpful if you think about what is the y divided by x. This is our tangent. So we saw that if we have a radius of 1, r equaling 1, called a unit circle, since we have a unit circle, we're looking at the sine of an angle theta is y divided by 1, which is just y. That means that the y value is the ratio that we seek for each of the given angles. We also know that cosine follows a similar pattern, being x over 1, and therefore x. That means that the x value in each coordinate is the cosine ratio that we are seeking. And once again, this is for a unit circle. Our tangent, we know to be, so a tangent of a given angle is y divided by x, or the opposite over the adjacent. In this case, we can even say it is sine of theta over cosine of theta. Once again, that's one of our ratio identities for tangent. The other is the cotangent, and it is the reciprocal cosine of theta divided by sine of theta. Now, along with this information, we're just going to go ahead and very quickly fill in our tangent. So our tangent at 0 is our opposite over, or our adjacent over hypotenuse. And let's try that again. Our y divided by x. And so our tangent of 0 degrees has to be 0 over 1. Then we're looking at the tangent of 30 degrees is going to be y divided by x, and this gives me root 3 over 3 when I rationalize my denominator. Y divided by x is 1 at 45 degrees, and y divided by x is root 3. And we finish with 90 degrees, and y divided by x is going to be 1 divided by 0, and that is undefined. Now, if you wish, you can say also no solution or not possible. I would accept all three of those answers. But ideally, the most precise is undefined. Now, in addition to this, we are going to have to work with the idea of the quadrants. After all, we know, based upon our quadrant, that our x values are positive in the first, but negative in the second, then negative in the third, and then positive in the fourth. And I'm going to make a chart for that, where we have our quadrants going up. 1, 2, 3, and 4. We're looking at sine, cosine, tangent. Then we have those three reciprocal functions, and they have the same sign as the originals. They would be the cosecant, that's the reciprocal of sine, the secant, that's the reciprocal of cosine, and the last one is the reciprocal of tangent, which is cotangent. Now, since sine is positive in the first and the second quadrant, but negative in the third and the fourth, the cosecant is positive in the first and the second, but negative the third and the fourth. Cosine is positive in the first and the fourth, but negative in the second and the third. Because tangent is the ratio of sine divided by cosine, a positive divided by a positive is a positive, but a positive divided by a negative is a negative. A negative divided by a negative is a positive, and a negative divided by a positive is a negative. Cosine has the same operations as the secant, the tangent with the cotangent. So here is a table that shows when sine, cosine, tangent, secant, cosecant, and cotangent are positive and negative. Now the last thing that we have to add to this is the idea of a reference angle. The reference angle is the angle that is separated between the x-axis and the terminal side. So in the first quadrant, theta is the theta prime. Theta prime is what we call the reference angle. In the second quadrant, you'll notice that the reference angle is going to be the supplement. Since this is now my theta, theta prime is sitting right here, and it is made by 180 degrees minus the angle. Once again, that's identifying our supplement. In the third quadrant, we can see that we are now over 180 degrees, which is right there, and therefore our great big angle going all the way through is not only our angle, but it's our angle plus our supplement. So we can say that the supplement, theta prime, has to be our given angle minus 180 degrees. The last one is all the way over here in the fourth quadrant. You'll notice that we are approaching 360 degrees with our angle theta, and this is our theta prime right here. Since 360 is right there, if we move forward, we can see that it has to be 360 minus our given angle. Now, it is important that we are able to identify our reference angles because it's the reference angles that give us which part of the first quadrant are we working with. You see, if I can find that a reference angle is 60 degrees, then I know that my angle has to be with the 60-degree coordinate. Either 1/2 root 3 over 2, root 3, or the reciprocals for tangent, cotangent, secant, cosecant, etc. So it's important that we first figure out what is the reference angle, what quadrant is this angle located in, and then we can find our ratio. And it requires us to use all of this information that we have on the page right here. Let's go ahead and take a look at a couple. You got this today. For those of you who are not in my class, I recommend that you just take a moment. You might want to take a screenshot of that first half. Then take the screenshot of the second half. And you notice it goes all the way up to 74. Okay, here we go. So if I'm starting with the sine of 90 degrees, let me zoom in a little bit. That's not zooming in. There we go. So if I have 90 degrees, sine of 90 degrees means that I am working with the 90-degree angle, and I can clearly see that my y value is 1. So I stop and I say, first quadrant, 90 degrees, y value 1. My ratio is 1. Number 2, sine of 30 degrees. 30 degrees is in the first quadrant. In the first quadrant, our point is going to be, for 30 degrees, root 3 over 2, 1/2. And so we want to take the y value, which is 1/2. Therefore, the sine of 30 degrees is 1/2. Then we take the tangent of 60 degrees. The tangent of 60 degrees in the first quadrant works with the 1/2 divided and root 3 over 2, and we would have root 3 over 2 divided by 1/2, which gives us root 3. That's what we've already found. So our answer is root 3. 120 degrees. 120 degrees is greater than 90 but less than 180. In the second quadrant, the reference angle is 180 minus 120 for 60 degrees. I am therefore looking at the reciprocal of a cosine at 60 degrees in the second quadrant. In the second quadrant, the cosine is negative. The reciprocal of 60 degrees is 1/2 flipped to give me 2. So my answer is -2. Number 5, 60 degrees. 60 degrees is in the first quadrant. It is its own reference angle. Therefore, we're looking at first quadrant, positive for a cosine, the reciprocal of the cosine at 60 degrees. The cosine of 60 degrees is 1/2. The reciprocal is 2. The answer is 2. 240 degrees. 240 degrees is in the third quadrant. It is greater than 180 but less than 270. To find the reference angle, take the 240 degrees and subtract 180. You get a 60-degree reference angle. We therefore want the tangent's reciprocal of 60 degrees. We know the tangent at 60 degrees is √3, and the reciprocal has to be √3/3. We know that the cotangent, just like the tangent, in the third quadrant is positive. So my answer is √3/3. We then move to the next one. Tangent of 145 degrees. First of all, it's in the second quadrant, greater than 90 but less than 180. The reference angle has to be 180 minus 135, which is a 45-degree angle. We know that the 45-degree angle for sine and cosine are both √2/2, and therefore the tangent would be 1. We are looking at 1 in the second quadrant, which is now -1. Let's go to number 8. 180 degrees. We call these quadrantal when they're sitting on the axis. Now, all we need to remember is that we're dealing with, for the cosecant, that our y value is 0. The reciprocal of 0 is undefined. Sine of 45 degrees. We know that a 45-degree angle is √2/2, and that is my ratio. A negative. Now, we know that the cosine and the secant are even functions, and when we have an even function, the negative drops away. But when we have an odd function, which are all of the remaining functions, tangent, cotangent, sine, and cosecant, the negative comes out in front, and we evaluate it as a 60-degree angle. So we think of a 60-degree angle, which is for sine, √3/2. We take the reciprocal, and we get 2√3/3. That is my ratio. 330 degrees. It is greater than 270, but less than 360. When we take the 360 and we subtract 330, we get a reference angle of 30 degrees. We know that in the first quadrant, 30 degrees is 1/2 for a sine function. Therefore, we are looking at it in the fourth quadrant, negative, below the x-axis, and we have that 1/2. Our answer is -1/2. Cosecant of 120 degrees. This is in the second quadrant. Cosecant, like sine, is positive in the second quadrant. I know it's a positive. If I take 180 and I minus 120 degrees, I get a 60-degree angle. With a reference angle of 60 degrees, I know my sine is √3/2. Taking the reciprocal, I get 2√3/3. Cosine of -240 degrees. Being an odd function, the negative goes away and becomes a positive. I know that in the third quadrant, the reference angle is the given angle 240 minus 120 degrees. 180 degrees, which gives me a 60-degree angle. Now, I know that cosine as a 60-degree angle is going to end up being 1/2, And then in the third quadrant, it is a negative. So my answer is negative 1/2. Cosine 210. 210 degrees is in the third quadrant. To find the angle, we take 210 and subtract 180, and we get a reference angle of 30 degrees. We know that the cosine of 30 degrees is root 3 over 2. In the third quadrant, cosine is negative. My answer is negative root 3 over 2. The secant of 135 degrees. 135 degrees is in the second quadrant. 180 minus 135 is a 45-degree reference angle. Taking 45 degrees and looking at the reciprocal of a cosine. Since cosine of 45 degrees is root 2 over 2, the secant is root 2. Being in the second quadrant, cosine is negative. 210 degrees. Once again, third quadrant. 210 minus 180 is a 30-degree reference angle. The tangent of a reference angle of 30 degrees is root 3 over 3. In the second quadrant, tangent is positive. My answer is root 3 over 3. Tangent of 150 degrees, second quadrant. 180 minus 150 degrees is 30-degree reference angle. We then say the tangent of a 30-degree reference angle is root 3 over 3, and in the second quadrant it is negative. We then go to the cosine of 0 degrees. The cosine of 0 degrees is 1. Once again, that's a quadrantal. Sine of 300 degrees is in the fourth quadrant. It is greater than 270 but less than 360. When I take 360 minus 300, I get a reference angle of 60 degrees. The sine of a 60-degree angle is root 3 over 2, and in the fourth quadrant we're looking at a negative. So I have negative root 3 over 2. Cotan of 90 degrees. Cotangent of 90 degrees is quadrantal. It is the reciprocal of our 1 over 0, which gives us 0 over 1, and the cotangent is 0. Cotangent of 330 degrees. This has a reference angle of 30 degrees in the fourth quadrant. It is a negative ratio, and we know that the cotangent of a 30-degree angle is root 3 over 3. Now let me think about that a minute. Nope, wait a minute. That's just root 3 for a 30-degree angle. Once again, we're talking about the cotangent. That's the reciprocal of root 3 over 3, which is root 3. Cotan of 30 degrees. Well, the cotan of 30 degrees is root 3. Sine of 240 degrees is a 60-degree reference angle in the third quadrant, so we know we have a negative, and it's root 3 over 2. Sine of 150 degrees, 180 minus 150 is a 30-degree angle. The sine of a 30-degree angle is 1/2, and in the second quadrant, sine is positive. This is how it goes, over and over and over again. Tomorrow, or on Thursday when I see you, you'll be doing more of these. This is the main part of what we need. Without the ratios, we can't graph, and this is what we're trying to get to. Hopefully this has helped. If you like this, please remember to click like. Otherwise, if you have suggestions for me, please feel free. I will continue to do this tomorrow when we go into radians, and we'll work with both radians and degrees. Thank you very much, Hornets. I hope you have a very good and safe evening. Take care and be well. Cheers. Bye-bye.